Hello students, so as we have discussed in the last lecture, what are the different methods to find out the order of reaction. Okay, so see, these are all the methods, 5 methods by which we can find out the order of reaction. Integration method is there, then graphical method is there, half time method is there, differential method, and postwards isolation method. So in this lecture we are going to cover these 2 methods. Okay, one is integration method, other is graphical method. Okay, after that for the next lecture we'll cover one more method. Okay, so by this way we are going to see all the 5 methods by which we can find out the order of reaction. Now we'll see first the integration method. See what happens in the integration method. For a given reaction, the values of which values, this small a, okay, then small b means concentration of reactant A, concentration of reactant B, so concentration of product formed after time t, and concentration of reactant remains after time t. Okay, all these values are obtained from the experiment. Okay, from the experiment we are going to find out all these values, and then we are going to use the actual expression. So all these values are entered in the rate equation of first order reaction kinetics and second order reaction kinetics equation. Okay, see, these are the 2 expressions which you can see on your screen. This is first order expression, this is a second order expression. Now see, the values of rate constant obtained by both the equation, okay, that both the expression and the expression which gives constant value for the rate constant, that is said to be the order of reaction. Means what? If I am getting value of K constant for the first order kinetics, then we can say the whatever reaction is there, that is first order reaction. Okay, and if I am getting the value of K constant for the second order rate expression, so that is that reaction is called as a second order reaction. Now how it is such, don't get confused here. See, this is what the inversion of cane sugar. So you are reacting this with the water molecule and you are getting see now these 2 molecules, okay, that we have studied in the previous lecture. So what we are doing here, so reaction is carried out, okay, at 298 Kelvin, means at 25 degree Celsius. Okay, this reaction is taking place. So what we are going to do, we are going to measure the inversion. We are going to measure the inversion. So at the initial, we are going to measure the inversion. Okay, there was no inversion. After 1800 second, we are again going to check the inversion. What is inversion over here? Okay, in mole per dm cube. After 3600 a second, we are again going to measure the inversion. So initially only when we saw the inversion of cane sugar, there only I told you that we are going to check out the inversion of cane sugar at the different time interval regularly. Okay, so we are going to find out the 6-7 reading, and after that we are going to check out whether the reaction is first order or second order. Okay, see here after 4500 second we are going to take the reading by using polarimeter. After 7800 second we are again taking the reaction that inversion using the polarimeter, and after 10,800 second we are going to measure the polarization. Okay, that is the inversion. So we are taking how many readings we have now? 1, 2, 3, 4, 1 minute, 5 and 6 readings are with us. Okay, so from where? From here we are going to find out the value of what? A, then A minus X, that already we have seen. If you see the slide, see here. Okay, from here we know how to find out the value of A, how to find out the value of X, how to find out the value of A minus X, and this is what the rate expression for that. Okay, you know it very well. So as we have value of A, X and A minus X, we are just going to put these values in the first order rate equation and second order rate equation. So this is what the first order rate equation. Okay, This is a second order rate equation. Okay, so by finding out the values of a minus x and x, okay, in the fashion which we have studied already. Okay, now what happens, see here, for the first order reaction, if you find out the value of each reading, value of k for each reading, value of k for each reading. So for first reading, what we get, at the first reading it was a 0, that don't bother about that. So after that we have taken reading after 1800 second. Okay, for that k is equal to how much, 5.795 into 10 raised to minus 5. See here, 5.97 into 10 raised to minus 5, 5.932 into 10 raised to minus 5, 5.963 into 10 raised to minus 5, 5.820 into 10 raised to minus 5, right? Now, if you put value of a, x and a minus x in the second order rate equation, what values you are getting now? 6.13 into 10 raised to minus 5, 6.667 into 10 raised to minus 5, 6.055 10 raised to minus 5, 7.56 into 10 raised to minus 5, 8.078 into 10 raised to minus 5. If you observe, see, these are the values seems to be constant. You know, 5 point, everywhere there is a 5 point something is there. Okay, but if you see here 6 point, 6 point, here 7 point something, 7 point something, 8 point. So as you are getting a value of k constant for the first order rate equation, then you can say that whatever reaction we have studied here, which reaction, in origin of cane sugar, is said as a first order reaction, because these values are constant. Okay, these are the values found out for, see, this reading, after this reading, yeah, after this reading. So we have total 5 readings. Okay, so for each reading we are finding out the value of k, and which remains a constant for the first order reaction rate equation. Okay, so here k is a constant, so hence the order of reaction is first order reaction. Okay, I think concept is very clear to you. Now next, graphical method. What we are doing, already we have plotted 2 graphs. Okay, for first order rate equation and second order rate equation, 2 graphs were there. So for first order, log of a upon a minus x versus time. Everywhere you will find here time is on x-axis. Okay, time is on the x-axis. Only on y-axis the term changes. Here log of a upon a minus x versus time, log of a minus x versus time. Okay, then for the second order, where n is equal to 2, okay, x upon a minus x versus time, and 1 upon a minus x versus time. So the pair of graph which gives a straight line, remember, either this pair will give you the straight line or this pair will give you the straight line. Okay, getting my point? Either this pair give you the straight line or this pair will give the straight line. The pair which gives you the straight line indicates the order of reaction. मग वरच्या ज्या व्हॅल्यू आहे ना या इक्वेशनच्या, ह्या ज्या व्हॅल्यूज आहेत, या तुम्ही ज्या सर्व व्हॅल्यूज घेतलेल्या आहेत, या व्हॅल्यूज जर इथे कॅल्क्युलेशन मध्ये यूज केल्या आणि ग्राफ प्लॉट केला, या इथे जर ग्राफ प्लॉट केला आणि इथे जर स्ट्रेट लाईन मिळाली त्या व्हॅल्यूज इन्सर्ट करून, सो व्हॉट यू विल से, द equation is or the reaction is a first order reaction. Or you are not getting straight line over here, but you get the straight line for the second order rate equation by using these 2 graphs. If you plot these 2 graphs, you are getting a straight line. One is a positive and one is a negative, that you have already seen. Okay, so you can say here the reaction which is given over here, or the which is studied over here, is a second order reaction. Very simple. Okay, you have to just see by which equation or in which case you are getting the straight line. Okay, so in a general you can say, in a general, if n is the order of reaction, a plot of what, 1 upon, in bracket, a minus x raised to n minus 1 versus time t will be the straight line with the slope n minus 1 into k and intercept 1 upon a raised to n minus 1. Okay, so from the slope, rate constant k can be determined. Don't bother this much about this much. Okay, so don't bother about this. you just focus for these two parts. Okay, this is what the general sentence given by the book. Okay, so these are what the two method. I think it is what the first is the integration method, by which you are going to find out the value of k for first order reaction and second order reaction, and you are getting the constant values of k for the first order rate equation. Hence you said that the order is a the reaction is first order reaction. And here in this case, wherever you get the straight line, either for the first order graph or second order graphs, if you get the straight line, or where if you get the straight line here, you say second order reaction. If you get a straight line for here, you say the first order reaction. Okay, this is for this lecture only. Okay, so for the next lecture we'll see next method.